Hi, today I'll be reviewing Le Chatelier's principle for AP chemistry. So let's get started. So what is Le Chatelier's principle? Le Chatelier's principle basically states that if an equilibrium is disturbed by changing any of the conditions at that specific equilibrium, the system or reaction will work to counteract the changes created and reestablish the same equilibrium. So I'll just be going over basically what are the effects, what are the shifts that can occur and how are they counteracted, and do a couple of problems along the way. So let's get going. So the first thing we have to know is with increasing or concentrating or decreasing or diluting the concentration of a substance. So if you increase the concentration, the reaction shifts away from that substance in order to use up the extra particles to reestablish the equilibrium. So basically, if you're increasing the concentration, you're using up more particles. And so the reaction has to use those particles up and create more products or more particles on the other side in order to reestablish the same equilibrium you had before. If decreasing the concentration or diluting, which basically removes particles, the reaction shifts towards the substance in order to produce more of the substance in order to make up what was removed. So basically, you're trying to create more products or more reactants if something was diluted in so you can have the same amount of equilibrium, well, the same equilibrium constant that you had as before. So let's try this problem over here. So what direction would the reaction shift if we decrease the concentration of hydrogen? So like the reaction could shift left, which is a forward reaction, or it can shift right, a reverse reaction. And what we're doing is that we're decreasing the concentration of hydrogen. And as the concentration of hydrogen is decreased, you need to have it be the same. So you have to add more hydrogen. And the only way you can add more hydrogen is to use up more NH3. So the reaction would shift left. So let's go on to pressure. So increasing the pressure of a system. So pressure is 1 over volume. And this, I believe you should know from Unit 3, gas laws in AP chemistry. So if you lower the volume and basically increasing the pressure will make the reaction shift to the side with the fewer moles of gas. So if you're increasing the pressure, you're lowering the volume. And one trick to remember is that if you're increasing the pressure, you're lowering the volume, and lowering is fewer moles of gas. So it's inversely proportional. So if you're increasing the pressure, fewer, decreasing the pressure, greater. So this one, so decreasing the pressure of a gas will make the reaction shift to the side with greater moles of gas. So I hope you understand this. It's not that bad as some you get. So let's try this problem over here. So what would happen if the pressure of the container holding the molecules decreased? So if the pressure decreased, then you basically have the volume increasing. And when volume increases, it shifts to the side with the greater amount of moles, greater moles of gas. So if the pressure decreased, then you have to just count the coefficients. So there's 8 moles over here, 2 moles over here. So the reaction would shift right in order to, as there's a higher, sorry, as there's a lower pressure. So it'll shift right. Increasing or decreasing temperature of a reaction. So increasing temperature is basically when the reaction, so if you increase the temperature, so to get the system back to equilibrium, the reaction wants to counteract any changes. So if you increase the temperature, the reaction will shift away from the increased temperature and will want to lose energy. And as it wants to lose energy, it releases that energy. So the reaction that releases energy is an exothermic reaction, decreasing the temperature. So when you decrease the temperature, the reaction wants to gain more. Like if you have like a cold substance, it'll want to gain heat. And when the reaction shifts towards the heat, it wants to gain or absorb energy. So the reaction is endothermic. So let's try this one. So what side would the reaction shift if the temperature was decreased in the reaction shown above? So if the temperature was decreased, you basically have the heat in the product side. So let's say if the heat goes, then the reaction will have to create more heat. So in order to create more heat, more reactants must be consumed in order to go to the product side. So the reaction will shift right. Catalysts. So catalysts do not affect the reaction in any way, shape, or form. And this is due to the rates of both the forward and reverse reactions being affected the same by a catalyst. So there's not any benefit for either side. So both sides counteract the changes, so it's basically the same as it was before. Common ion effect. And I won't be going too in-depth into this as I already made a video of it, but basically the common ion effect is when you add a substance with a common ion to a reaction which is already at equilibrium. So let's try this for, I don't know, PbCl2. So this is like a solid, like it's like a slightly soluble salt. And at equilibrium, it creates, sorry about the lag, Pb and Cl minus. And both of these are aqueous solutions. So basically there's an equilibrium that's already established, but if you add more, like let's say AgCl, let's say if you add AgCl to this. So Cl is basically a common ion between the PbCl2 and AgCl. And what's already at equilibrium is disrupted by the addition of the AgCl, with Ag as basically a spectator. Actually, let's not do AgCl, my bad. Let's do NaCl, that's a better one. So basically the sodium or Na is a spectator. And so what happens is that due to there being so much Cl ions, the reaction will shift to the left in order to consume it and basically create more of precipitant. And that will just decrease the solubility in order to keep the equilibrium the same. So whenever you have like a common ion added, it decreases solubility. So let's try some more practice problems. So let's do this one first. So consider the following system at equilibrium. PCl5 gas is at equilibrium with PCl3 and Cl2. How will increasing the concentration of PCl5 shift the equilibrium? So if you have an increased concentration of PCl5, in order to bring the equilibrium back, you have to decrease it. And the only way to decrease it is to consume it. In order to consume it, you have to create more products. So the reaction will shift to the right. So let's try the other one. So how will increasing the concentration of PCl3 shift the equilibrium? So when you increase the concentration of PCl3, you have to consume that PCl3 in order to get it back to equilibrium. So the only way you can do that is shift it to the left. So along with that, you have two more problems. So increasing the pressure on the following equilibrium, which way does the equilibrium shift? So remember, when you increase the pressure, you're going to the side with the fewer amount of moles. And that can be determined by coefficients. But the problem is that both sides have the same amount of coefficients. So 1n2 plus 1o2 creates 2no. So that's basically the same. So basically, what happens is you basically have no shift as there's no change. There's no greater amount of moles on either side of the reaction. Let's try this one. Increasing the pressure on the following equilibrium, which way does the equilibrium shift? Actually, let's not do increasing, let's do decreasing. So if you decrease the pressure on the equilibrium, it'll go to the side with the greater amount of moles. So the side that has the greater amount of moles is 2CO and O2. So the reaction will go to the right. So I guess that's pretty much it. So I hope you gain a better understanding of Le Chatelier's principle, as that's one of those topics that you need to get like a good grasp on. I'll find some practice problems that I'll link down below, and I hope you have a good day and stay safe.